Hey guys, welcome to the method of partial fractions case 2. So we already talked about when the rational function p of x over qx is proper, but what happens if in case 2 if p of x is not a proper integral? Well, what that means is that the degree of the numerator in this case is going to be larger than the degree of the denominator. So when this happens, what we're going to do is we're going to use polynomial division first, which is going to yield a polynomial of the form p of x over q of x. If you divide that out, is going to equal some polynomial plus the remainder over the divisor. Okay, so that's the general form. Then what we're going to do is we're going to use partial fractions on r of x over q of x, and then we're going to integrate g of x plus r of x over q of x. So once we find the partial fraction decomposition of that, we're going to integrate this whole thing here. Okay, so let's look at a couple of examples. Okay, example 1. Evaluate the integral of x cubed plus 1 over x squared minus 4 dx. So the numerator has a larger power, so we're going to go ahead and perform long division, which we're expecting at this by now that you know how to do this. So we're going to have x cubed plus 1 over x squared minus 4. When you polynomial divide that, you get x plus 4x plus 1 over x squared minus 4. So the r of x over q of x is 4x plus 1 over x squared minus 4. That is what we're going to do and partially decompose that, partial fraction decomposition. We're going to do that to this fraction. So we're going to multiply through by x plus 2 times x minus 2 because we want to get rid of that denominator, okay, that denominator, so we don't want any fractions. So when we do that, we get 4x plus 1 equals a times the quantity x minus 2 plus b times the quantity x plus 2. Okay, so now what we want to do is we want to find the values for a and b. Now it's only a and b because there's only two factors in the denominator, x plus 2, x minus 2. Now, to find a in my case, I associated a with x minus 2. Okay, so b is going to be with x plus 2. We want to get rid of the b term. We want to eliminate that. So we're going to let let x equal negative 2, which is going to eliminate the whole b term. So I'm going to plug in wherever I see x a negative 2, and I've done that here. 4 times negative 2 plus 1 equals a times negative 2 minus 2. So negative 7 equals negative 4, so a is going to be equal to 7/4. To find b, we want to eliminate the a term, so we're going to let x equal 2. That's going to eliminate the a term, and similarly we can find b, which ends up being 9/4. So we found the partial decomposition. Okay, so now we're going to integrate the g of x plus. Well, the g of x, remember, way back at the beginning was x. So x plus, here's the partial decomposition. So here's p of x over q of x. There's the partial decomposition. So I'm integrating all of this. There's the g of x and the partial decomposition. So like before, let's swing the numerators out front, which I've done in green here. So I swung those out front. So I'll integrate x dx plus 7/4 times the integral of 1 over x plus 2 dx plus 9/4 times the integral of 1 over x minus 2 dx. And this is where that integral of natural log will come into play. When I integrate all of this, I get 1/2 x squared plus 7/4 times the natural log of x plus 2 plus 9/4 times natural log of x minus 2 plus c, and those are an absolute value. We want to keep natural log a positive value. So that's our first example where we have an integral that's not proper. Okay, so let's look at one more example. In this case, I have x squared plus 2 over x plus 3. We're going to integrate that with respect to dx. First thing we want to do is polynomial division. So when I divide that out, I get x minus 2 plus 7 over x plus 2. There's only one factor here. So we're only looking for a. And so when I look at the partial fraction decomposition, look at how I set that up. A is going to be 7. Okay? You could multiply through here by x plus 2, but you could do the math and you're going to see that a is going to be equal to 7. They're the same fraction. What's a? A has to be 7 for them to be equal. So not a lot of work there. So I can go ahead and integrate pretty quickly. And I do that here. So here is the integral of x minus 2. Okay, there was my g of x, right? dx plus the integral, and there's the partial fraction decomposition, dx So I could bring the 7 out front, but when I go ahead and do this, I get x squared over 2 minus 2x plus 7 times the natural log of x plus 2. That's an absolute value, plus c, and I'm done. So those are a couple of examples of case 2 when p of x divided by g of x is not a proper integral, it's improper. Okay, the degree of the numerator is greater than the denominator. Okay, if you guys have any questions or comments, you can type them below, and we'll see you next time.